So, this is another video in the series from Math 1073 for UTSA. We're going to be dealing with Module 1.1 today. So, basically, we're solving systems of linear equations. In this case, we're doing two equations at a time, two equations with two variables, x and y, most of the time. And so, for the first problem, we are going to determine whether the given ordered pair is a solution to the system of equations. So, for this example, is 7 comma negative 5 a solution to that system? And basically what that means is this ordered pair a solution to this equation and also to that equation? If it's not a solution to either one, then it's not a solution just to the system. So basically, you just work by plugging in. 7 plugs in for x, negative 5 plugs in for y, and if we total up to 10, well, then it solves the first equation. I say it, the ordered pair. So 2 times 7 plus negative 5. Is this equal to 10? Well, 14 minus 5. No, that is not 10. So this is not a solution. Not a solution. And I don't even have to check the other equation. Maybe it solves the other one, but I don't need to check because it doesn't solve the first one. Therefore, it does not solve the system. Remember, when you were looking for the solution to the system of equations, it's something that solves both at the same time. Let's try this one. I'm assuming this one will be a solution. One example isn't, the other one is what I'm guessing. So again, I'm going to plug in the x coordinate for x and the y coordinate for y. And so we get 4 times negative 4 minus 7 times 5. Is this question mark negative 51? Well, I've got negative 16 minus 35. Yeah, that is negative 51. That checks out. So the first equation is solved. So let's plug into the other equation. So 7 times negative 4 minus 3 times 5. Is this negative 43? Okay. Well, negative 28 minus 15. Little mental math. Yeah, that's negative 43. Sure. So this checks out. So yes, this is a solution. Yes, is a solution. But trying to write neatly here. There we go. So basically, if you plug in into each equation, pick one to go first. It doesn't matter what order you check in, and if the order pair solves both, then that's a solution to the system. And if it fails to solve either one, well, then you don't have. And again, I never even checked the second equation. It doesn't matter because we failed with the first one. So, next example, next problem. For the following exercises, solve the system of equations using substitution. Is this one the same thing? Yeah, that one's fine. Okay, so basically substitution is a method for solving a pair of equations or a system of equations. Basically, you pick one of the equations and you either solve for x or solve for y. You get one by itself, and then you plug into the other equation. So in this case, since x has a coefficient of 1, I'm going to solve for x. So I'm going to pick this first equation, copy it down here, x plus 3y equals 5. And I'm going to subtract 3y on both sides. X equals 5 minus 3y. Okay. Now, if I'm looking for the solution, I'm looking for the pair of numbers that match both equations. So I'm going to take this equation and substitute in for x. So I'm going to plug 5 minus 3y into x. Okay, so 2 times 5 minus 3y plus 3y equals 4. And what happens is I now have an equation with one variable. This is now a linear equation. So I'll distribute the 2. So I have 10 minus 6y plus 3y equals 4. And I'll combine like terms. So 10 minus 3y equals 4. And I just want to get y by itself, so I'll subtract 10 on both sides. So negative 3y equals negative 6, right? 4 minus 10 is negative 6. And I'll divide by negative 3 on both sides. So y equals 2. So now I have the y coordinate of the solution to the system. So now what I'll do is take this y value and plug it into this equation for y. So x equals, sorry, trying to write neatly here, equals 5 minus 3 times 2. So 5 minus 6, so negative 1. So the ordered pair solution is negative 1 comma 2. So that's the solution to the pair of equations, or the system of equations. And if I wanted to go back and plug in to check that it really does solve both, I could do that if I want to be extra careful, but I don't think I've made a mistake here, so I'm not going to bother doing that in this case. How about this one? So this one's a little bit messier because I've got a decimal now. It's a little bit of a pain. Again, with this one, I'm looking at the coefficients, negative 0.2, negative 10, 2. This is a coefficient of 1. So I think that, again, I'm going to want to take the first equation, or the top equation, and solve for x, and that will make things slightly easier. So let's take this guy, x minus 0.2, y equals 1. One thing I could do, if I wanted to, is multiply both sides by 10, because that will allow me to, or by 5, multiply both sides by 5, because that will allow me to get rid of the decimal. That's optional. It doesn't really matter. But since this one, we took the first equation and solved for x, I want to do this one differently. Solving for x, again, might be the most straightforward thing, but I want to do things differently. I'm going to multiply by 5 on both sides, and you'll see what I mean. When I distribute the 5 on the left to the x and to the y, I'll get 5x minus 1y equals 5. So now it's a y that has a coefficient, well, not 1, but negative 1. But it's not 10 or 11 or something like that. It's 1, essentially. So I'm going to basically, I'm going to add 1y to both sides. The order in which you do this is optional. I could have kept y on the left. I just chose not to. Then I'll subtract 5 on both sides. So 5x minus 5 equals y. This allows me not to deal with decimals. That's why. That's the main reason I did this at the beginning. I wanted to avoid dealing with decimals if I could. So now I can substitute into here. So negative 10x plus 2 times 5x minus 5 equals 5. Okay. So I'm going to distribute. So negative 10x plus 10x minus 10 equals 5. I'll combine like terms, and I get negative 10 equals 5. What does this mean? Right? Well, when that happens, that means there's no solution. What it means is that these two lines are parallel if you graph them. They do not cross, so there's no solution. So when you start doing substitution, you're basically assuming that there is a solution to find, and you're just going through the motions to find it. So when you get a contradiction like this, that means that there is no solution, and it was never going to work to begin with. So we'll say no solution. Okay. All right. Now, that's not to say that these two lines are perpendicular, right? That just means that these two lines cross. They are, I'm looking at them, they are not perpendicular if you graph them. You can tell by looking at the coefficients involved. Notice that if I look at these guys, if I take the top row and multiply by negative 10, this coefficient here is 1 times negative 10, of course, is negative 10. Negative 0.2 times negative 10 is 2. So the bottom coefficients are a multiple of the top coefficient. That tells me, oh, these are parallel, basically. There's a little more to it than that. There are some exceptions, but that's the general idea. So now we're going to solve using elimination. Elimination does the same job as substitution, but it just works differently. So with elimination, what I need to do is I'm going to add the two equations together, or subtract. So I'll take the two left-hand sides, add them, add down, combine like terms, and then the right-hand side, add down, combine like terms, essentially. But we have to do some setup. What I want to do is I need to multiply this equation by something to get either this to match or these guys to match. So if I were to double, and by match I mean like having 5 and -5 or 8 and -8. I want them to be the same size number, but one's plus, one's minus is ideally what I have. So if I were to double the top row, the top equation, I'd have -6 here. So when I add down, these would cancel out. I'd eliminate y. Alternatively, if I want, I could take this equation and multiply by 3 on both sides. I'll have 6 here. So when I add down, x's cancel. It doesn't really matter which one you do first. I'm going to start with taking the top equation, and I'm going to multiply by 2 on every term as I go, as I write it down. So negative 12x minus 6y equals negative 150. And then I'll just copy the other equation below that. And then I'll put like a big line I'm adding, and I just add down. So negative 10x plus 0 equals negative 80. Okay. Negative 10x equals negative 80. And then I can divide by negative 10 on both sides. So x equals 8. All right. Now, how do I find y? Well, one option is to revert back to substitution. Oh, I'll just plug 8 into this equation for x, and I'll get y that way. Or I could do the do I have room? I have room. I could do the other thing I talked about, where I take this equation and triple it. So what I'll do is I'll triple this one. So 6x plus 18y equals 210. And I'll just copy the other equation above it without changing anything. Okay, and then I'll add down. So I'll get 0 plus 15y equals, was that 135, I believe? Yeah, that seems right, 135. Okay, so I'll have 15y equals 135, and then I can divide by 15 on both sides, so y equals 135 over 15. I think this divides evenly. I'm pretty confident. I think it's 9. Yeah, 9. That's right, 9. Okay, so the ordered pair solution is 8, 9. The solution to this pair of equations. So, last example? Yeah, last example. We're going to do this one with elimination as well. So, I don't like having all these fractions, so I'm going to take the top equation and multiply by 24 on both sides. So 3/8 x plus 1/3 y equals negative 11, 13. I'm going to multiply by 24 because 8 times 3 is 24. And then the next equation, the bottom equation rather, I'm going to multiply by, if I can write a y, I'm going to multiply by 6 on both sides because 6 is a multiple of 3, so I don't need to use 18. Okay, so, and I'm going to keep the brace, the curly bracket. So, when I distribute the 24, I'm going to have 24 times 3 over 8. That reduces to 9. So 9x. When I distribute the 24 here, I'll have 8y. So plus 8y equals, I guess that's negative 156. No, it's negative 302, I believe. Question mark. Let me grab a calculator. I'm pretty sure that's right. 312. Well, I'm glad I checked. I really could have done, multiply it out by hand like this, but whatever, it's fine. So the next row, when I distribute the 6 here, I'll have negative 2x. And then when I distribute the 6 here, I'll just have plus y equals 36. Okay. So now I can do my elimination. And I think probably I want to eliminate y first. So I'm going to multiply the bottom row by 8. So 9x plus 8y equals negative 312, negative 16x plus 8y equals 8 times 36, that is 288. Now you might say, well, didn't you say that we need to have the numbers match, but one's plus, one's minus? But we're going to subtract here, okay? So 9x minus 16x, that's going to be positive 25x. 8y minus 8y is 0. Negative 312 minus 288. 288 is negative 600. Okay, so I'll have 25x equals negative 600. I'll divide 25 on both sides and get negative 24. Okay. Now to get the y value, again, over here, because I didn't have to modify any of these, and none of these have a coefficient of 1, doing the second stage in elimination as well made a lot of sense. With this one, however, here y has a coefficient of 1. So if I take this equation and I add 2x to both sides, I'll get y equals 2x plus 36. I'm just going to do substitution now. Just plug x into there. So I'll get negative 48 plus 36. So y equals negative 12. So the solution will be negative 24 comma negative 12 for that system. Okay, and that's basically it.